So, let's talk about precision versus accuracy, significant figures, uncertainty, and some applications for them. All these topics are things that are necessary to understand for chemistry. Significant figures, or sig figs, are when you estimate an extra digit when measuring as an attempt to get a more accurate result. We cannot make a measurement that is more precise than what our measuring abilities allow, so we will want to only estimate one digit further. This is how we develop sig figs. There are some rules for sig figs, which include 1. Non-zero digits are significant. These are digits that are anything except 0. 2. Zeros in between non-zero digits are significant. 3. Leading zeros are not significant, that is, zeros that come before the first non-zero digit. 4. Trailing zeros are significant. These are zeros that come after the last non-zero digit. And remember, when adding and subtracting with sig figs, use the fewest number of decimal places. What does it mean to be precise, and what does it mean to be accurate? Being precise means that you are able to recreate the same outcome multiple times, but it does not mean you are exactly hitting the target you were hoping for. Being accurate means that you can hit the target you were aiming for, but maybe not very consistently. Let's say someone was an archer and they were trying to hit a bullseye. If they were to hit something like this, they would be precise because they can get the same outcome consistently, but they aren't hitting the center. Now, if they were to get something like this, then they would be pretty accurate. They were able to hit the target they wanted, but not really able to replicate it. Now, if they were to hit something like this, then they would be both precise and accurate. They're hitting the target, and multiple times too. But what about this arrow? It's almost on the bullseye, but not quite. This is where we can apply our third topic, estimation. When taking measurements, you sometimes get different values. These are called uncertainties. One way to remove an uncertainty is by averaging all the results. Let's say we have a ruler, and the object we are measuring is not quite 2.5 centimeters, and not quite 3 centimeters. This is where uncertainty would come into play. To measure the object to the best of our ability, we would have to estimate. Here, I think a solid guess would be 2.7 centimeters. Remember, it's important not to overestimate the uncertainty. We can only guess one digit over what our tools give us. Now, how can we use this in real life? Well, sig figs are often used in math and science to make calculations easier. Some numbers that go on forever, like pi, we can shorten using sig figs. We also use precision and accuracy in sports to determine the skill of a player. One good example is the sport of archery, like previously mentioned. We estimate all the time too. If we go grocery shopping and buy some apples, we have to weigh them. The scale sometimes estimates it instead of measuring the exact weight. Thank you for listening to this video, and good luck on the quiz!